All right, so today we are looking at 4.6, which is kind of asking what happens when some of our solutions are imaginary. So the deal is, whatever the degree of your polynomial is, that has to be equal to the number of zeros or solutions. So up until this point, all of our solutions have been real numbers. So some of these solutions are going to be imaginary then. So for example, say I have a polynomial that has a degree of 3. So maybe that polynomial looks something like this. So I can tell my degree is definitely odd here because of my end behavior. But when I look at this, it only touches the x-axis once. So that disagrees with this statement right here. This is saying whatever my degree is, that's how many solutions I have to have. So that just means I have one real solution and 2 imaginary solutions. So if my degree is 3, it only touches the x-axis once, so there have to be 2 more solutions somewhere. They would have to be imaginary. Let's say, for example, we had a degree of 4. And my polynomial looked like this. So I can tell my degree is even because my end behavior, both ends are going down. And this does not touch the x-axis at all. But my degree is 4, so there have to be 4 solutions. So there would be 0 real solutions and 4 imaginary. Okay, so the degree is 4, there have to be 4 solutions. Does not touch the x-axis at all, so there are 0 real solutions. That must mean there are 4 imaginary. So let's look at an example of how we're going to actually figure out what these solutions are. So here's my equation, and I want to see what my solutions are here. So there are 4 terms, so I'm going to try factoring by grouping. So when I look at these first 2 here, I can take out an x squared, and I'd be left with x plus 3. When I look at my next 2, I can take a 16 out. And I'd be left with x plus 3 again. So I finally would have x plus 3, x squared plus 16. So when I think about continuing to factor, x plus 3 I know is done because x to the first power. When I look at x squared, though, I want to think about, can that be factored anymore? So if I look at a times c, I have 16. So 1 and 16, 2 and 8, 4 and 4. So I have no middle term, so I would have to have factors that cancel each other out. So if I'm looking at 4 and 4, positive 4 and positive 4 don't cancel each other out. And if I made one negative, I would have to make the other negative to still get a positive 16, which those don't cancel each other out either. So I know this cannot be factored anymore. So if I can't factor anymore, I set each of my factors equal to 0. So here I end up with x equals negative 3. Here I end up with x equals, when I take the square root of each side, plus or minus because I'm taking the square root. The square root of 16 is 4, and that negative gives me an I. So there's where my 3 solutions come from. So I had a degree of 3 originally. I have 1 solution here and 2 here. So I have positive 4i and then negative 4i. Let's look at another one. So we have x to the 4th plus 6x to the 3rd plus 12x squared plus 8x equals 0. So to start, I see I have a GCF here. I can take an x out of everything. So I'm going to go ahead and do that. And then from there, I have 4 terms, so I'm thinking about factoring by grouping. So if I do that, and I take an x squared out, I would have x plus 6, plus I can take 4 out, and I'd have 3x plus 2. So These do not match up, so factoring by grouping did not work. So what I have to try now is using that rational root theorem. So my constant is 8. So I want to list my factors of 8. My lead coefficient is 1, and the factors of 1 are just 1. So my possible solutions for my possible solutions, I'm going to take all the factors of my constant and divide them by 1. Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So those are what I'm going to kind of start with and look at here to see what my possible solutions are. So I'm going to start with 1 and see if that works. So my coefficients are 1, 6, 12, and 8. So when I do the synthetic division here, I did not get 0, so I know this does not work. So we would just keep kind of trying here until we figure out what does work. So if I try -2, just because I may or may not know what the answer is supposed to be. I get a remainder of 0, so this one does work. So that means my factor, let's see, I already had an x out in front here. From this, I know one of my factors is now x plus 2. And then I want to look at these coefficients. So if that started with x to the third, this would be 1x squared plus 4x plus 4. All still equal to 0. So then, x can't be factored anymore. X plus 2 can't, but I still want to look at x squared plus 4x plus 4. So my a times c is 4. So thinking about factors of 4, 1 and 4, 2 and 2. So 2 and 2 would add up to give me that middle piece of 4 here. So when I factor this, I would have x squared plus 2x plus 2x plus 4 is 0. So I'm bringing this just along. My first two pieces I can take out an x. My second two pieces I can take out a 2. So I end up with my x plus 2. And then from here I get an x plus 2. And then my pieces out in front is another x plus 2. So I have 3 x plus 2's here. So my solutions would be x equals 0. And then from each of these I get x equals -2 3 different times. So my degree to start with was 4, so I ended up with 0, and then I got -2 1, 2, 3 times, so that would be my total of 4 solutions there. Alright, let's look at another example. We have x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8 equals 0. And I'm solving here. So, I can't do factoring by grouping. There's too many terms. There's not a GCF I can pull out. So I would have to start right away with that rational root theorem and think about some solutions. So my constant is 8. So 8 is 1 and 8 and 2 and 4. My lead coefficient is just 1, so I'm looking at 1 there. So not a very big list of possible solutions. So my possible solutions are plus or minus 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So looking at that, let's go ahead and try 1. So what I have to pay attention to here is that there's no x to the 4th term, so I do need that placeholder. Okay, so I'm going to do the synthetic division now. So I do not get a remainder of 0, so 1 did not work. That's fine. Let's just try something else. Let's try or no, negative 1. So negative 1. So I would have 1, negative 1. So here I do get a remainder of 0. So at this point I have x plus 1, because I know this is a factor. And I'm left with x to the 4th minus x to the 3rd plus 2x squared minus 4x minus 8 all equals 0. So I still am left with something that is too much to do factoring by grouping. So the deal is I have to try that rational root theorem again. So this time I'm looking at this polynomial, and I'm going to look at my constant, which is still 8. So 1 and 8 and 2 and 4. My lead coefficient is still 1, so 1. So my possible solutions are the same. So let's try, we tried 1 and negative 1. Let's go ahead and try a 2 now. So doing the synthetic division here, I do get a remainder of 0, so I know 2 is a solution. So I have to carry down this x plus 1. From here, I get x minus 2. And then from here, I get the remaining polynomial. So this is x to the 3rd plus x squared plus 4x plus 4. And now I'm down to my 4 terms, so I can go ahead and try factoring by grouping. So here I can take out x squared, and I'd be left with x plus 1. Here I can take out a 4. I'd be left with x plus 1. So grouping does work because I got x plus 1 both times. So I would have x plus 1, x minus 2, another x plus 1, and then x squared plus 4. So I have to think about, is this factored completely? And yes, it is. X squared plus 4 cannot be factored anymore because a times c is 4. No factors of 4 will cancel each other out to give me 0 as my middle term. So when I solve, I get x equals negative 1, x equals 2, another x equals negative 1. Now I want to think about x squared plus 4 equals 0. So x squared equals negative 4. So when I take the square root, I get x is plus or minus 2i. Okay, so I want to think about how many solutions did I get? I got 1, 2, 3, 4, 5, because of the positive and the negative version. And when I started way up here, my degree was 5. So it matches up just like it's supposed to. All right, so the last thing we want to talk about is writing a polynomial. So we did this last week, Friday. Only we did it with just real numbers. So we want to think about what does that look like with imaginary. So if I'm given solutions negative 4 and I. So what I have to think about, the only way I can come up with an I is like, if we look at the last one, at this very last situation here, is if I take a square root and I get a negative under the square root. So I would have to have the positive or the negative. So I also have to have not just I, but negative I. So this works just like with the square roots. So last week we had like square root of 3 as an example, and we had to add in negative square root of 3. Same deal with the i's. They told me I was a solution. Negative I then has to also be a solution. So what I'm going to set up here are my factors. And I want to keep those i's together. So I'm just going to bring down the x plus 4, and then I'm going to do my distributing here. So when I simplify, those two cancel each other out. And if you'll recall, I squared is equal to negative 1. So negative 1 would really be a positive 1. And then I can go ahead and distribute those.